Hi guys, good morning. Good evening it is, right? So only one student. Okay, we'll wait.
So from solid state,
Yeah.
what and all questions will come, sir? Packing efficiency.
Packing efficiency that Z is equal to D is equal to Zm by Na cube formula, and then
That's sensitive, sir.
based on octahedral and tetrahedral holes, they'll ask you to find the formula of the compound.
Oh,
Ready,
sir.
right? So those kind of questions only will come.
Defects will they ask, sir?
Defects, if they ask, it will be this thing only, conceptual questions, not like any form problems will come.
Or
Okay,
like
and
they'll
that
give
too.
this these some cation is not there. What kind of
Something
defect?
like that. Something like that. Just only conceptual questions, not any problem. Problem will not come. No.
Then, sir, from surface chemistry,
Surface chemistry is purely theoretical, purely conceptual questions.
colloids and adsorption, only that, sir, and
Yeah,
emulsions.
colloids, absorption. What else? Yeah, these two only. Surface chemistry and colloids. Yeah,
Okay, sir. Okay, sir.
maybe
Thank you, sir.
purely theoretical. Yeah. And maybe you will get adsorption isotherms. You have finely charged isotherm, right? Adsorption isotherm.
Yes, sir.
K, we have something like x by m is equal to k p power 1 by n, this formula. So
Yes.
from this, maybe you can get graphical questions. In the sense that if I take log on both sides, I'll get log x by m is equal to log k plus 1 by n log p. So if I draw a graph between log of x by m and log p, you are going to get a straight line. Oh, sorry, this is log k, right? You're going to get a straight line like this, and the slope of this would be 1 by n, and the intercept would be log k. So again, this kind of problems can come. They'll give you the values and then they'll ask you to find out. That's it.
Okay, sir.
Okay, right. So yeah, 3 of you are there. Okay. So there is this book. If you have like queries regarding particular chapters, there is this JEE chapter-wise previous years. So they will have, I would say this is like last 30 years of every question chapter wise according to solutions. I can show you the book. Maybe 1 second, just give me a moment. I'll show you the book.
So I have it, sir.
You have it. Then you can check it there. No, you can see what kind of questions you're getting from each and every type, every chapter, which area they're asking more number of questions, less number of questions. All these things will be there.
Yes, sir.
Right. So yeah. Okay, now I'll see how many are there. Still only 3. Great. Okay, maybe I will 7-6 it is. 17-6 it is. We'll start. Okay. Right. Okay, so we were seeing stoichiometry, correct? So I'll just directly go for the problems. Okay. Right. So they're telling that I have this reaction, NH3 plus HCl gives NH4Cl, and they're telling that 17 grams of ammonia is mixed with same amount of HCl, in the sense that 17 grams of this reacts with 17 grams of this. They're asking you how many grams of NH4Cl is formed. Go for it. So remember, whenever stoichiometry problems are going to come to you, right? Whatever the type of data which is given to you, say it can be in terms of mass, it can be in terms of volume, it can be in terms of number of particles, whatever the type of data you have, you convert that into number of moles. Okay, then you do stoichiometry. Whatever data. So now it's given in terms of mass. You know how to convert it into number of moles. Then do the stoichiometry. Now see again, as I told you, you have given information about two of the reactants, right? So you have to find what is the limiting reagent, what is the excess reagent, and based on what is the limiting reagent, you decide what is the product. Okay, right? Go for it. First, which is the limiting reagent here?
HCl.
HCl is the limiting reagent, correct? Right. Fine. So it's pretty simple. So if I convert this into number of moles, so here the molecular mass of ammonia is 17. So here I'm going to get 1 mole, right? And here, if you check, HCl's molecular mass will be 36.5. Hydrogen 1, chlorine is 35.5. Correct. So this divided by 36.5 is definitely going to be lesser than 1 mole. Okay, whatever the number of moles, we'll calculate that. Okay, so what you see from the reaction is that 1 mole of ammonia requires 1 mole of HCl to form 1 mole of NH4Cl. Correct, right? So here I have 1 mole, but what you see here is here I have lesser than 1 mole, right? So definitely this is what is my limiting reagent, right? This is my excess reagent. Done. Right now, based on now, forget about the excess reagent. Now, consider the limiting reagent and tell me. I mean, you have to know. You have to get what is the amount of products formed. Right. So if I calculate this, whatever is the number of moles here, 1 mole of this gives 1 mole of this. So the number of moles formed here would be 17 divided by 36.5 moles. Right. But what they're asking you the answers in terms of mass. Right. So this into the molecular mass of NH4Cl is going to give me the answer.
Sir, approx 25 grams. Sir.
Approx 25 grams. Yeah, 24.92. Yeah, that's the answer. Correct. So if you calculate this thing, so it will be 17 plus 36.5. So it will be 46, 53.5. Yeah. 1 second, guys. 1 second. Right. Sorry, guys. Okay. So this approximately, yeah, you should be getting 24.92 grams. Approximately, yes, 24 grams. Okay. Done. That's the question. Okay. Fine. Next question. Okay. So anybody has any doubts in this? Pretty simple. Like if you just remember the yesterday's, if you just remember the Haber's process, I have explained everything there, right? Okay. Now in the next question, I will introduce you to the percentage yield. Okay. Now in all these problems, say yesterday's problem, today's, whatever the problem you have seen, please understand that you have been assuming that the reaction is going to undergo 100% completion. Right? Only if everything converts to this, then I will be getting this much amount of the product. Right? But what if, say, only 80% of the reaction is happening, only 80% of the reaction is efficient, the 80% there's only 80% yield in the reaction. Right? So in those cases, obviously, now what you have to do in those kind of questions is that you just do it assuming that it is 100%. Right? Now, if it's going to be 80%, just take this thing and take 80% of this amount. That is, this will be into 0.8, and whatever the answer you get, that would be the answer, that would be the amount of product formed for 80% yield. This, whatever the value you have here, is what is my value for 100% yield, right? So if they tell that it's going to be some percent, just take the percentage value of this and get the answer. Okay, that is what is going to be percentage. Okay, we'll take a question now. Right, so the reaction given to you is Fe2O3 plus 3CO gives 2, okay, I'll write it there only, 2 Fe plus 3 CO2. This data is given, this reaction is given to you. Okay, and they have also told that I'm going to have 480 grams of Fe2O3, and okay, they have given 480 grams of this thing, and they have given excess amount of CO is given to it. They have now, they themselves have given that is going to be the excess pH. They didn't give you any amount regarding that because we don't need it, right? Once I know which is the limiting reagent, I'll be able to say what is the product. Okay, so they have given that 480 grams of Fe2O3 is there, and which is reacting with excess amount of carbon monoxide, right? And they're also telling that they got 256 grams of iron, right? The iron molecule, the iron which is getting formed is 256 grams. Now what they're asking you is the percentage yield of the reaction. Can you do it? Okay, now what you do, exactly same thing, right? You know that this is the limiting reagent. Okay, now convert this into number of moles and see if like do the stoichiometry and see how much amount of iron I'm going to get. Definitely that amount will be greater than this amount, because if you do that, it is going to be 100% completion, but whatever amount you have is going to be a value which is far lesser than 100% completion. Okay, now you will be able to compare the values, whatever you got for 100%, whatever value you have, then you will be able to see what is the percentage yield or percentage completion of the reaction. Go for it. I've told you how exactly you have to do. If you want, what is the atomic mass of iron? Atomic mass of iron is 56. Again, I'm telling, please convert everything into number of moles. If you are very good at doing that, you can actually do it with mass directly, but yeah, you
Sir,
need to have
82%.
82%. No, there is no choice like that. The choices I have are 100%, 91.2%, 75%, and 50%. These are all the values I have. Anybody else has any other answers? Is there anything in the chat? No. Okay, fine. So we'll do it, right? So if I calculate what is the molecular mass of Fe2O3, molecular mass of Fe2O3 is 160, right? Okay, so this divided by 160 is gonna give me 3 moles. Okay, so 3 moles of Fe2O3 are there, right? So if you look at the calculation, 1 mole of Fe2O3 gives me 2 moles of Fe, right? So if I have 3 moles of this, can I say I will be getting 6 moles of this? Again, if you're getting confused, do like this: 2 moles Fe2O3 gives, oh sorry, 1 mole Fe2O3 gives 2 moles Fe. So if I have 3 moles of this, if you find X, it will be this way. X is gonna become 6. Anyways, or pure logical, you don't have to go through so much this thing. So anyways, so I have to get 6 moles of Fe, right? So now I need to know what is the molecular mass. I mean, I need to know what is the mass of the 6 moles. So if I have to multiply this by 56, so 5 this into 60, 300 plus 36 will become 336 grams. Okay, I should have got 336 grams of Fe for 100% completion. But how much I'm getting? I'm getting only 256. Right, now you can easily calculate the percentage, 256. Or if at all you are a little bad with mathematics, you can do like this. Again, the cross multiplication will work. How? For 100% completion, you are getting 256. For some X%, you are getting sorry, for 100% completion, you're getting 336 grams. For X percentage, you are getting 256 grams. Then you can cross multiply and find out. Or anyways, you're going to get the same thing here: 256 divided by 336 into 100, you're going to get the answer. Okay, so 256 divided by 336, how much? Okay, approximately, if I have to do 0, so if I put a 0 here, so if I put say 7 times would be 2100, 2210. Yeah, so it's going to be almost I'm getting 70 odd percentage. So the option which is going to match with me is 75%. Again, rough calculation, right? So the answer is the yield of the reaction is only 75%, not 100%. Anybody has any doubt in this, how I did the problem?
No, sir.
Okay, fine, good. Right, fine. Now one last question in stoichiometry. We'll do a little tough problem. Okay. Okay, I hope I can cut this part. Everybody has taken down. Okay. Actually, this is a similar problem. I can do it here itself, actually. Fine. So they have given gallium reacts with oxygen to form GaXOY. Okay, we don't know the formula, right? Right. So what they have given is 1.25 grams of this, right, of gallium reacts with some amount of oxygen. They didn't give the amount of oxygen, but what they have given is they have given that the amount of GaXOY is 1.68 grams. Okay, so this much amount of gallium reacts with some amount of O2 to give this much amount of the gallium oxide. I don't know what is exactly the formula of the gallium oxide. Tell me what is X and Y. Think about it.
So gallium atomic mass.
Yeah, gallium atomic mass is 70. So it's actually an integer type question. So there are actually they're not asking you X and Y, they're asking you X plus Y. That is definitely going to be an integer. In integer means it is going to be a value between 0 and 9. Obviously, it can't be 0. Yes, please don't sit idle. If I am anyways going to solve, I know how to solve this problem. It's not about that. Please try. Yes, any answers? Okay, fine. I'll help you out. We'll see what is there. So obviously we don't know what exactly is the stoichiometric equation, right? But what I can tell is, say from this, I can say that some X moles of this reacts with Y by 2 moles of this, because there's O2. Okay, so X moles of this reacts with Y by 2 moles of oxygen to give GaXOY. That we can say. Correct. Okay, fine. Now I'll be able to easily calculate what is X, right? Because I know what exactly is there, right? So 1.25 divided by 70 is what is my X. Done. Okay, right. Okay, fine. Now what I understand is X moles of gallium. Okay, X moles of gallium is actually giving me 1 mole of gallium oxide. Correct? Can I say that X moles of gallium gives me 1 mole of gallium oxide? Right? So, so if I have, okay, so X moles should have given me, but what will I do with that? X moles of this gives me 1 mole of this. Okay, fine. So X moles of this gives me 1 mole of, so basically 1 mole of, okay, we don't know what is X. Fine, no issues. Okay, fine. So what happens is, I can do this. See, GaXOY, right? Now I can say here that X moles, or I would say X into 70 grams, right? X into 70 is basically going to be the mass of gallium reacting, because I know it is X moles, right? X into 70 is what is the mass of gallium. X into 70 gallium plus Y into 16 of oxygen. No issues. X into 70 of gallium plus Y into 16 of oxygen is actually going to weigh how much? 1.68 grams. Correct? Okay, this is the mass of gallium, this is the mass of oxygen. The total mass I know is going to be 1.68. Right? Now I know what is this X value, right? So X value is what? 1.25 divided by 70 into 70 plus 16Y is going to be equal to 1.68 grams. That's it. I've solved for Y also. Correct. So 70 gets cancelled, right? So you basically have 16Y is equal to 1.68 minus 1.25 will become 1.43, right? So now Y value will be what? Y value will be 1.43 divided by 16. Okay, so that's it. Now you have to calculate what they're asking you, X plus Y value. So X value is this, Y value is this. Just add them both. You are going to get the answer. Very simple problem. Okay, if at all, I'll repeat again. So fine, I'm just doing based on this X and Y, I'm balancing the reaction basically. Okay, so here I'll have X moles of this, and Y by 2 moles of O2 gives me GaXOY, 1 mole of that. Okay, so I can easily calculate what is the X value, because they're giving me the mass of gallium reacting, so that divided by the molecular mass is what is going to be the X. Done. Right. Okay, now going to here, total mass is given, how much ever is formed is given, that is 1.68, right? So obviously still muted. Okay, fine. Cool. What I was telling? Yeah. So X moles of gallium plus Y moles of oxygen. If I just take the mass of them, it is going to be 1.68, and that's exactly what I have done here. X into 70, it is the mass of gallium. Y into 16, that is the mass of oxygen. That is equal to 1.68. X I've already calculated. So you solve for Y, you got the Y value also, and get the X plus Y value. Okay, pretty simple problem. Very simple problem. Okay, so that is about stoichiometry. So we talk about limiting reagents, we talked about excess reagents, percentage yield of the reaction. All these are the type of questions can come, right? And you need to know how you tweak with mathematics, right? How you play with mathematics, that also matters here, like this kind of questions. Okay, fine. So the next thing is about the concentration terms. But I'm not going to teach you that because again we'll be seeing them in solutions, molarity, all these things we'll again be seeing in solutions. So at that time we'll solve problems. And before that, I'll give you the definition from the formulas. Again, we'll do that when you go for solutions chapter. Okay, fine. Here now what we'll see is the equivalent concept. We saw mole concept. We saw how to do stoichiometry in terms of moles. Now we'll see what is this equivalent concept and what and all I can do with this, and how my equivalent concept is better than your what is that mole concept. Okay, right, fine. Okay, fine. So equivalent concept I'll teach you. Okay, fine. So first we have to know what is this equivalent mass. Okay, fine. Take down the definition. It's just equivalent to your molecular mass, but again, little difference will be there. Please take down the definition for equivalent mass. Okay. So basically, we'll talk about equal. So for different species, we have different this things. So we are talking about first equivalent mass of metals. Okay, equivalent mass of metals is what we're talking about, and from there we'll just stretch it. Okay, fine. So it is the mass of the metal required. It is the mass of the metal required to react with. It is the mass of the metal required to react with 16 grams of oxygen. 16 grams of oxygen or 1 gram of hydrogen. 16 grams of oxygen or 1 gram of hydrogen or 35.5 grams of chlorine, Cl. That's exactly the definition. Again, I repeat, it is the mass of the metal required to complete. I said, I think I missed the point completely, but it's understood. Okay, so it is the mass of the metal required to completely react with 16 grams, 16 grams of oxygen, 1 gram or 1 gram of hydrogen, or 35.5 grams of chlorine. That's the definition, right? Okay, say for example, let me see if I have any problem directly. I think that will work. Equivalent concept. Just a moment, people. Okay, fine. Maybe I can make my own question. Not a big deal, right? Right. So I have a metal, right? So which is going to form an oxide, which is MXOY. Okay, is going to form MXOY, and so this metal obviously has to react with some amount of oxygen to form this MXOY, right? say or actually I can give you something. Okay, M2O3 is what is the oxide formed. Okay, I think that is done. Now, so much information is not required. So there is a metal, right? There is a metal which forms an oxide of the form M2O3. Okay, there is a metal which forms an oxide of the form M2O3. Now, what is the equivalent weight of the metal? Equivalent mass of the metal is how much? Something. It's a very simple question. Okay, so if you understand the definition, now you are set for this problem, right? Okay, now what you understand is okay, so what do I understand is in this compound, right, M2O3, we'll see how much amount of oxygen, what is the mass of oxygen present. Okay, so basically there are 3 moles of oxygen, correct? So can I say 48 grams of oxygen is present, right? 48 grams of oxygen is present, or I would say 48 grams of oxygen is required to react with the metal, right, to form this oxide. Okay, now I say 48 grams of this oxygen is required to react with metal for forming the oxide. Now, what I have to know is, by definition, what it says. If I have 16 grams of oxygen, for that, how much metal is required is what is my equivalent mass. Correct? Okay. So for 16 grams of oxygen, whatever is required is what is my equivalent mass. Right. So I don't know what I should have actually given the mass. I should at least give the molecular mass of the metal. Say, assume that the molecular mass of metal is 23. He's giving you a random value. Okay, fine, or 27. That's aluminium, because N2O3 is going to be Al2O3, just like that. Okay, so they have given what is the molecular mass of the metal, right? So what I understand is from this formula M2O3, what I understand is 3 moles of oxygen, that is 48 grams, 16 into 3, 48 grams of oxygen is required to react with 2 moles of metal, that is 54 grams. Okay, now by definition, what it says, the amount of metal required, so this is my equivalent mass of the metal which is required to react with 16 grams of oxygen. That is what is the equivalent mass of the metal. So if you do the calculations, you will be getting 54 into 16 divided by 48. So this will go 3 times, done, and 54 will go how many times? 1 time, and then 18. Yeah, so 18 grams is the, but how it will be 18 grams, I'm not sure. Oh. Guys, I made a mistake. It's not 16 grams of oxygen, it is 8 grams of oxygen. Please change the definition. Okay, please change the definition. It is the amount of metal required to react with 1 gram of hydrogen, 35.5 grams of chlorine, or 8 grams of oxygen, not 16 grams of oxygen. I'm so sorry. Okay, it is going to be 8 grams of oxygen. So it is not going to be 16 here. It should be 8 grams of oxygen to react with whatever is the equivalent mass of the metal. Right. So if you do that, it's actually now it's going to be 8 grams. Right. So this will be going 6 times and this will be going 9 times. So yeah, so the equivalent mass of the metal is 9 grams. That's the answer.
Sir, if you're going to say it's 8 grams of oxygen, means it also has to be 17 grams of chlorine.
Yeah, by definition, I'll tell you this will work when I give you another formula. When I give you the formula, you will actually see why is it like this. Okay, so this is how it is defined, people. This is not what is the definition I am giving. This is what is the scientific definition of what equivalent mass is. Right now, you will be able to understand what exactly is this if I give you one formula. I'm going to give you the formula, then you'll be able to cross check it. Okay, please wait for it. Okay, you'll be able to confirm it. There is a proof which is coming to you. right? Okay, so this is one way of finding the equivalent mass of the metal by using the definition. Okay, now there is another way of doing it, as I told you, with the help of some formulas, right? Now let me do that for you. So hope there is no question here. Okay, so equivalent mass is equal to the molecular mass of the any or molecular, or I'll say molar mass. It can be atomic mass or molecular mass divided by something called as n factor. Okay, right? So molecular mass is equal to equivalent mass is equal to the molar mass of anything, some species, divided by something called as n factor. So we know what is molar mass, that we can easily calculate. What do you mean by this n factor? This n factor is going to be different for different kinds of chemical species, right? For example, if you have, say, a metal or a non-metal, or in general an element, right? Now the n, which I'm talking about the n factor, the n factor would be its valency. Okay, the n factor would be its valency. So I can easily tell, for example, if I take aluminium, right? Aluminium's molar mass or atomic mass is 27, and I know what is the valency of aluminium, which is going to be 3. Or you remember, if at all it is going to be a metal, it is going to form a cation, right? So non-metal will form an anion, right? So you just take the magnitude of the charge, and that again will give you the valency. Either way. Okay, right? So either way, valency or the charge formed by the magnitude of charge, obviously positive, negative doesn't matter, right? The magnitude of charge formed by these metals and non-metals by forming their cations and anions, that will also be the n factor for metals or say in general elements, right? Okay, so 27 is the atomic mass of aluminium. So I know aluminium forms Al3 plus. So obviously 27 divided by 3 will become 9 grams. So I hope you understand like how the previous problem and this are connected. Okay, so there also you got 9 grams only for aluminium. As like I told you, 27 was the molar mass of the metal, and whatever it's going to form Al2O3. You know that. So you saw the 9 grams here also it's going to be 9 grams. Okay, right? Fine. So that's about elements, right? For example, if you want to find for nitrogen, now nitrogen will form N3 minus. So nitrogen would be 14. That's the atomic mass. So this is for nitrogen. Nitrogen will be 14 divided by 3 would have been the equivalent mass of nitrogen. So hope you understand. It's pretty simple. What the n factor for metals is the valence. Okay, right? Fine, cool. Next one. Say I'm talking about equivalent mass only. Obviously, for if I have any ionic species, right? For example, if I have an ionic compound, how will you find it for an ionic compound as such, right? So assume that I have some mx plus and some say O, or I cannot take O, say some I take non-metal, say n is the anion. Okay, some ny minus. Okay, so if you look at the formula of this, I can easily tell that the formula would be my nx. This would have been the formula. Anyways, you'll be able to find the charges from the formula. Okay, now if at all you have an ionic compound like this, how will you calculate the equivalent mass of the whole compound is the next question. Pretty easy, right? So now what you have to do is just take the metal and the cation and anion separately and find their equivalent masses separately, and then you add them both. That will be the equivalent mass of the total compound, in the sense that for this compound, if I have to calculate the equivalent mass, right, it would be like this. The molar mass of M divided by what is the charge? Charge is X plus molar mass of N divided by what is the charge? Charge is Y. This would have been the equivalent mass of this compound. Equivalent mass of this compound would be the sum of the cations is the equivalent mass and the anions is equivalent mass. Pretty simple. Okay, right? So or any other compound is given, even if it's going to be a covalent compound. right? For covalent compounds, just take all the elements present, and you can easily calculate what is their equivalent masses and sum it up. You are going to get the total equivalent mass of the compound. Okay, pretty simple, right? Okay, next. That is for any compounds for that matter. We saw for elements separately, for compounds separately. Then, right? Then we go for acids or bases. Okay, so for acids or bases, the N factor is going to be their acidity, or if for acids I call it as basicity, or the acidity. Okay, basicity or acidity. You know what is basicity and acidity, correct? Basicity is the number of H plus that particular acid can give, and acidity is the number of OH minus that particular acid can give. Right? So it's pretty simple. So if I ask you what is the equivalent mass of H2SO4, pretty easy. The molecular mass of H2SO4 is 98, and it can give me 2H plus. So divided by 2 will become 49 grams as the equivalent mass of H2SO4. And if I ask you what is the equivalent mass of NaOH, now we know the molecular mass of NaOH is 40, and it can give only 1 OH minus. So divided by 1 will give, it will be same. Divided by 1 will be again 40 grams. But if at all it was MgOH twice, then you would have taken the molecular mass of MgOH twice divided by 2, because it will give me 2 OH minus ions. Okay, so that is for acids and bases. That is the equivalent concept. So the equivalent mass of acids or bases. Okay, so that is about that. And lastly, we have, okay, hope you've taken this down. Pretty simple. Lastly, I have oxidizing or reducing agents. Okay, so oxidizing or reducing agents, we'll see about it when we go for redox reactions. Now we know generally oxidation is removal of electron. Obviously, the other things are there: addition of oxygen, removal of hydrogen. But those are a little lower classes definition. But if they've been there in 11th class, 12th class. Actually, I should speak in terms of oxidation number, but since I have not taught you, but you must have known anyways. So the thing is, for oxidation, it is removal of electron, and for reduction, it is addition of electron. Correct. So now when I say oxidizing or reducing agent, right? So an oxidizing or reducing agent will help in oxidation or will help in reduction. It is going to oxidize something. An oxidizing agent will oxidize something else, and reducing agent will reduce some other compound. Right. Now, if they are, say for example, if you take an oxidizing agent, if it is going to oxidize something else, now the question is how. The answer to the question is sacrifice, in the sense that for something to be an oxidizing agent, it has to undergo reduction. Same way, for something to be a reducing agent, it has to undergo oxidation. Ulta pulta. Right? It is going to oxidize, say oxidizing agent is going to oxidize something else by reducing itself. Same way, a reducing agent is going to reduce something else by oxidizing itself. Okay, now for the best example I can take now is KMnO4, because that's a world-class example I can have as an oxidizing agent. Okay, so now KMnO4, if I have to calculate what is the equivalent mass of KMnO4, I cannot directly find out. Okay, these are going to be reaction specific, right? For different reactions, I will tell you. Maybe we saw in buffer solutions when I taught you. I think I spoke about there. KMnO4 is oxidizing power, right? The power of this oxidizing agent is going to be pH dependent, right? I told you in acidic medium it's the strongest, in basic medium little lesser, and in neutral medium it is going to be still lesser. Okay, so in acidic medium maximum power, then basic medium, and the least oxidizing power will be in neutral medium. Right, now why it happens like this you can easily understand. Okay, so if I take MnO4 minus in acidic medium, okay, I have some amount of H plus present in the reaction medium. Okay, and I have some other reactants also, but I'm just going to concentrate on MnO4 minus here. So this MnO4 minus in acidic medium, which is going to form Mn2 plus. Remember, it's going to be an oxidizing agent. It has to undergo reduction, right? So you can easily calculate what is the oxidation number here, because you would have done oxidation numbers even in your coordination compounds chapter, right? So you can easily find out here. You will find that the oxidation number is +7, right? And here the oxidation number is +2, right? So you see there is gain of 5 electrons, right? Obviously, reduction is addition of electron. This is an oxidizing agent, has to undergo reduction by accepting 5 electrons, gain of 5 electrons. Okay, so please remember, for oxidizing agents or reducing agents, the N factor is basically going to be number of electrons lost or gained per formula unit. This is very, very important. Okay, and the N factor is going to be the number of electrons lost or number of electrons gained. The most important point is per formula unit. I'll tell you why is it so important. I'll take an example and explain you. Okay, fine. So if the reaction for KMnO4 is going to happen in acidic medium, now you see that the 5 electrons are gained, right? It is going to be electrons lost or gained, right? Now, obviously, for one formula unit, for one KMnO4 molecule, I'm going to get 5 electrons gained. Correct. So in this case, equivalent mass is going to be the whatever the molar mass of MnO4 minus divided by 5. Okay. Now, if you see, for example, in basic medium, if I have OH minus ions present in this, MnO4 minus will form MnO2. Okay, now you see here it is going to be +7, and you're able to see, right? Yeah, you're able to see. So MnO here it will be +7, here it will be +4 if you calculate the oxidation numbers. So you really see here I'm going to have 3 electrons gained, right? So in this case, the equivalent mass is going to be whatever the molar mass of MnO4 minus divided by 3, because 3 electrons are gained. Okay, right? So this is what is your equivalent mass of KMnO4. Okay, now I just want to specify what I just have to take an example and tell you what is this per formula unit. Okay, so is there any questions, guys, here? I hope everybody understood how do you calculate the equivalent mass of oxidizing or reducing agents. I hope there are no questions. Okay, moving on. I'll just explain you what do you mean by this per formula unit. Okay, so if I have K2Cr2O72 minus, right now it doesn't matter, potassium dichromate is what I'm talking about. That is also a strong oxidizing agent. Now that can be oxidizing agent only in the presence of acid, in the sense that it can be an oxidizing agent only in acidic medium. There is no question of going for basic medium or neutral medium. Okay, okay, fine. Before that, tell me, if KMnO4 or MnO4 minus is a neutral medium, tell me what will be the product form. In case of acidic medium, I form Mn2 plus. In case of basic medium, I form MnO2. What will happen if I have neutral medium? What will be the product form? What will be the reduced species of MnO4 minus? Do you remember? I told you this when we are looking at buffer solutions. Do you remember? Nobody remembers. Okay, fine. So if you don't remember, please understand it is going to be MnO4 2 minus. Okay, and here you will see that it is going to be +7 for MnO4 minus. Here it is going to be +6. If you calculate, it is going to be +6. So there's only 1 electron lost. So in neutral medium, the equivalent mass of KMnO4 and the molecular mass of KMnO4 is going to be same, because divided by 1 is going to form. And in fact, this is 1. Okay. Anyways, so remember this: acidic medium Mn2 plus, basic medium MnO2, neutral medium MnO4 2 minus. Okay, right. Fine. So if I take Cr2O72 minus, obviously the reduced form of this will be Cr3 plus. Right. Now, if you calculate the oxidation number here, it is going to be +6. And if you obviously there directly, I can say that it is going to be +3. Right. Now, you see there are going to be 3 electrons accepted. Correct. Right. So if I write that the equivalent mass is going to be the molar mass of K2Cr2O7 divided by 3, it is absolutely wrong. The n factor is not 3. Can you tell me what is the n factor? Any guesses at least?
3 by 2, sir.
No. Right. So first what you have to do is, here you see there are 2 chromium atoms. Here also you should have 2 chromium atoms first of all. That you should do. This is going to help you even in balancing. When I'm going for a redox reaction, all these things I'm telling you will be very helpful. Okay. So first thing you'll do is you'll put 2 Cr3 plus. Okay. Fine. Now for 1 Cr plus 6, there are 2 chromium atoms which is having plus 6 oxidation number. Again, I repeat, there are 2 chromium atoms which are having plus 6 oxidation number, right? So for one of the chromium 6 plus to become one chromium 3 plus, I require 3 electrons. But how many I have here? I have 2 chromium atoms in one formula unit. In one formula unit of K2Cr2O7 minus, I have 2 chromium atoms. For one chromium atom, 6 plus 2 becomes Cr plus 3. It is going to be 3 electron. So for 2 chromium 6 plus to become 2 chromium 3 plus, I require 6 electrons. That is this thing for the insignificance of this particular phrase, per formula unit. Per formula unit means for one formula unit, obviously you see in one formula unit I have 2 chromium atoms, right? So for one chromium atom, 3 electron. 2 chromium atom, it is going to be 6 electrons, and that would be the correct answer to this. N factor for this would be 6, not 3. Okay, be very careful. Okay, I hope everybody understood. Why is it 6 and not 3? Okay, fine. So that is about your equivalent masses of different species. Okay, now why are we going for this? Why are we doing this equivalent concept? Right now, I'm going to give you one more term. Okay, now we know what is equivalent mass. Okay, now you know how to calculate anything given to you. Now certain things are reaction specific, right? Certain things are going to just based on or whatever other stuff you have seen, right? So anyways, so next thing is we now know what is equivalent mass. Right. The next thing is a number of equivalents. Okay. Now, number of equivalents is similar to number of moles. Okay. So, how do you define number of moles in terms of mass? Given mass by molecular mass. Correct. Now, here it's going to be given mass divided by the equivalent mass of the compound or the metal. That's it. Very simple. Okay. Number of moles is given mass by molecular mass. Equivalent mass, number of equivalents is given mass by equivalent mass. Okay, right, fine. So that's about number of equivalents, right? Now when I go for stoichiometry with respect to this number of equivalents, what is the advantage? The advantage is that you do not need to have any balanced chemical equation. You don't have to balance the chemical. You don't have to balance the chemical equation. For most of the reactions you will be able to balance because it is sometimes easy. But if I'm going to have a very complex reaction, right? We can. Especially when I go for redox reactions, it is little. You know how time taking it is. Even though you don't remember the exact process, you definitely know that it's going to take some time, right? So you have to do that, and then go for mole concept. Do the stoichiometry. So much tedious process, right? Now, in this case, if I'm going to use number of equivalents instead of number of moles, you really don't need to have any balanced equation, right? Okay. Now, how does that work? It is really going to work mathematically. Trust me, it is really going to work like that, right? I don't have time to prove it to you that this will work like that only, right? But let me tell you an example. Say if I have H2SO4 plus NaOH, right? Generally, now if at all I'm going to do it in mole quantity, I have to put a 2 for NaOH because it has to get balanced. So I would have formed Na2SO4 plus H2O. This would have been there, and obviously I would have put 2 H2O here. Okay, right. So if I tell you, that 98. See, this is a very simple reaction. You'll be able to do it more confident. Also, just giving you an example. Say if I tell you that 196 grams of H2SO4 is there, okay, and say 40 grams of NaOH is there, right? And I'm asking you how much amount of Na2SO4 would have been formed. Okay, now the masses are given. Now you're going to use equivalent concept. Okay, that means you don't require balancing, right? And what you have to understand is whatever is the equivalence you have here. First of all, I need to check whatever is the limiting. Okay, first forget it. I'm going to give you only one this thing. Okay, only one information I'm giving you regarding H2SO, but nothing else is given. Okay, fine. So I ask you what is the mass of NaOH required and what is the mass of Na2SO4 formed. Okay, now what you do now, last time I did a stoichiometry, you converted whatever the data given to you in terms of number of moles, right? Now here what you do is you convert everything in terms of number of equivalents, right? Okay, first, hope you remember how to calculate the equivalent mass of this. Equivalent mass of this will be molecular mass of this divided by the n factor. N factor, I told you, for acids will be the number of H plus ions which can give, which will be 2, which will be 49 grams. Okay, so fine. So now this, if I find the number of equivalents, now it will be given mass divided by the equivalent mass. So that you will be getting it as, can I say it will be 4 equivalents? Okay, now you can blindly say that this is going to be 4 equivalents, this is going to be 4 equivalents, this is going to be 4 equivalents. That's it. You really don't have to balance it. If you just know what is the number of equivalents of one thing, all the other things are going to be the same number of equivalents. Okay, now if I include two such things, say for example, in this case, I told you that I had 40 grams of NaOH also. Correct, right? Now, if I had 40 grams of NaOH, and if you calculate what is the equivalent mass of NaOH, can I say equivalent mass and molecular mass are going to be same, because the number of OH minus it can give is only 1. Correct. So now if I calculate what is the number of equivalents, 40 divided by 40 would have become 1 equivalent. Right. Now, please understand, there is no question of going for 1 mole of this, giving me 2 moles of that, 3 moles of that. No, nothing. If I have 1 equivalent here, I require 1 equivalent here. If I have 2 equivalents here, I require 2 equivalents here. Right. So I have 1 equivalent, but I calculated here, I got 4 equivalents. So definitely, blindly you say that this is my limiting reagent, this is my excess reagent. That's it. Now you forget about the excess reagent and you tell that obviously 1 equivalent of this would have been formed and 1 equivalent of this would have been formed. That's it. Okay, so that is the advantage of having your equivalent concept. You really don't need to go. This is a very easy equation, so you can balance. But if I'm going to give you any redox reaction at that time, definitely you will find it difficult. Okay, fine.
Sir,
so let
after
us
finding the number of equivalents, what did you do?
then you can okay, fine. Now you can go for finding the mass also of this. Okay,
yes.
so what we'll do this. Okay, so first let me calculate what is the equivalent mass of this compound. Right, forget about H2O. Right, so H2O, because both are hydrogen and oxygen, so for H it will be 1. For anyways, we'll do it. Okay, wait. So for Na2SO4, I'll just calculate what is the equivalent mass first, right? So equivalent mass would be equivalent mass of Na plus equivalent mass of SO4 2 minus, and you know how to calculate for both of them, right? So equivalent mass, okay, let me write it up. Right, so equivalent mass of Na plus would be 23 divided by 1. No issues. Okay, so equivalent mass of SO4 2 minus, if I calculate, S sulfur is 32 plus 32 64 plus 32 64 plus 32 will be 96. Sorry, yeah, 96. Now what is the charge? Charge is 2, so it is going to be 48 grams, right? So 48 plus 23. 48 plus 23 will become 63, 71. 71 grams is the equivalent mass of what is that? Na2SO4. Right, now you have the number of equivalents, that is 1. Right, so number of equivalents is 1. given mass divided by the equivalent mass is 71. So the given mass of the total mass of Na2SO4 formed is 71 grams. That's it.
Sir, it's 4 equivalents.
What for? No. You saw that I showed you the 20. This is one equivalent. Or if at all you don't know this thing, yeah, then 4 equivalents. Then you keep this as 4 and then calculate. Not a big.
Sir, like for the given problem where you are given that 196 gram H2SO4, for that we have to take 4 equivalents.
Yeah. So if at all no data is given about the NaOH, then if I given 196 grams, yes, this is 4 equivalents. Everything is 4 equivalents. But if I given you NaOH as 40 grams of this, then there's only 1 equivalent. So this is a limiting reagent. So obviously I'll form only 1 equivalent of this. Then only this will change. Okay. So like this, you'll be able to find what is the mass. Okay. Right. Fine. Now, actually, let me give you a problem. It is gonna be helpful. Actually, any problem we can take and do it in terms of equivalence, but still not a big deal. Oh yeah, and I forgot one more thing, right? Okay, the one more concept is the time. Okay, fine. And that is normality, right? So normality is very similar to molarity. Okay, now we know what is molarity formula. Molarity, capital M, this is capital N. Molarity is number of moles divided by volume. If it is in ml, I have to put 1,000 here. If it is in liters, no 1,000. Right? Okay. Same way, normality N is equal to number of equivalents. Now you see number of moles you write here. Now here it is going to be number of equivalents divided by the volume in ml into 1,000. Okay, and you can easily convert normality to molarity or molarity to normality. Please remember the formula. Normality is equal to molarity into n factor. Okay, normality is equal to molarity into the n factor. You should have done titrations, right? In your 11th, or I don't think 11th class, not 12th class. In 11th class, you should have done some titrations. Obviously, I think you should have used it, but without even I did it. Okay, when I did my practicals, titrations and all, I think they will ask you what is the normality or molarity of some H2SO4 or something, or HCl, right? So you would have done all these calculations just without knowing anything, because I did it. Like you also would have done it, but if you know the theory behind it and done it, wonderful, great. But if you didn't do it, then you can know it now how it works. Okay, fine. So this is all. This also I wanted to give you, right? So we'll take just few problems, and then okay. So I think one problem, if I do, it will be sufficient, because we already done so much problems in stoichiometry in terms of number of moles. So I don't want to spend so much time here. Anyways, we'll do. Okay. But here everything is given in terms of molarities and number of moles. Okay, no issues. Right. So they are telling MnO4 minus is going to act as an oxidizing agent. Okay. Now it is going to oxidize chromium 3 plus to chromium dichromate ion. Okay. So anyways, I'll write the reaction for you. Right. So the reaction goes like this. Now they have given that this happens in acidic medium. Okay. So I have MnO4 minus reacting with Cr3 plus to form Cr2O72 minus, and I know in acidic medium MnO4 will form Mn2 plus. No issues? Okay, fine. Now what they have given the data. The data they have given is some volume of MnO4 minus and 0.2 m, right? Some volume of 0.2 m MnO4 minus reacts with 32 ml of 0.125 m Cr3 plus. Okay, now what they're asking is, what is this V? Okay, what is this volume is what they're asking. What is the volume required for MnO4 minus is what they're asking. Okay, fine. So let me help you here. Now first, since like I can't do this problem in terms of molarities, like I mean in the sense that I will be able to balance the equation and then I can do so many stuff, but I am not going to do any of that. I am directly going to use the equivalent concept. Okay, fine. So if I do that, let me convert every molarity term in terms of normalities. Okay, so and I know I told you that normality is equal to molarity into the n factor, right? So now if I just take for MnO4 minus, right? So MnO4 minus, the normality if I have to find, that would be 0.2 is the molarity, and n factor you have to calculate, right? You see here it's +7, here it is +2. So obviously the number of electrons gained is 5, right? So this into 5 will become 1n normality. Okay, so now I can write it as some volume of 1n MnO4 minus. Done. Okay, now going to this if I have to convert it in terms of normality, again normality of this, that is Cr3 plus, would be 0.125, right? 0.125. Now please understand, I have basic, now you, if at all for your little easy understanding, you put half here. Just why? Because I have 1 Cr and I just make out to share only 1 Cr. That's why. Okay, fine. So for 1 Cr3 plus to become 1 Cr6 plus, obviously you can calculate here, it will be +6. Now here I can easily say that 3 electrons are lost. Okay, now if it was ulta, that is Cr2O7 becoming Cr3 plus, then you have to put 2 Cr3 plus, then at that time n factor would have become 6. Now in this case the n factor is 3 only, because we are calculating for Cr3 plus. Correct. Okay, so this into 3, so 0.125 into 3 will become how much? This will be 15.
0.375.
0.375. Okay, thank you. Okay, so 0.375 n is what I have. Okay, so this is 1 n, this is going to be 0.375 n. Okay, now you have to obviously calculate the number of equivalents, and on whatever the number of equivalents I have here, that would be the same number of equivalents I should have for MnO4 minus, because obviously there's no question of limiting and excess reagents here. They want to know that complete reaction, whatever it is, right? So now how will you calculate number of equivalents? Can I say volume into normality will give me the number of equivalents? Just like volume into molarity will give me the number of moles, volume into normality will become number of equivalents, right? So now I can write V1N1 equal to V2N2, that 1 is for MnO4 minus and 2 is for Cr3 plus. So I don't know what is the volume for this thing. Number of normality for MnO4 minus is calculated as 1. Volume of this is given to be 32. What is the normality of this? 0.375, right? And that's what you can calculate. So I'll write it here. Volume will be equal to 32 into 0.375 divided by 1, obviously, because I have 1 here. So if you do the calculations, you're going to get the answer. Okay. Now this might, see, I did the problem. It is really not going to take much time, right? Because all of them are going to be whole numbers, multiplication like this, like this, like that. And it's going to be pretty simple. Okay. So now this is how you do the problem. Like, this is how you do stoichiometry in terms of equivalent. Okay. Right. Fine. I hope everybody understood. First step what I did is I converted molarity into normality. That's it. That I did using normality is equal to molarity into n factor. Right? Then only thing I used is V1N1 is equal to V2N2. V1N1 is basically going to give me the number of equivalents of MnO4 minus, and that should be same as the number of equivalents of Cr3 plus. Right? And one more small tweaking we did here. Generally, I said you for Cr2O7 2 minus, the n factor was 6, but for Cr3 plus the n factor is 3 only. Okay, so now that was the only difference we saw, and then I just did V1N1 is equal to V2N2 to find the final one. Okay, very easy problem, right? So it's 8:18. Maybe we'll just do one more problem. Maybe you will be able to do it, or I will give you the problem and you do it. No, guys, this is not a suitable problem. I'm not able to find a suitable problem for you. Okay, fine. I think, yeah, I think we'll stop with this. Right. So next class, okay, next class, that's it. This is about the stoichiometry chapter. I have covered everything as you asked for. Okay, we covered, not even one point was missed. Right. Okay, so the only thing which we missed is concentration terms, normality, molality, mole fractions, ppm, mass percentages, volume percentages, all these things that will go that we'll see when we go for solutions chapter. Okay, because that is also going to be an integral part. Without that, it's just going to be some formulas, colligative properties, 4 colligative properties, and the problems regarding that only, right? So yeah, that will be fine. And so next, I think tomorrow, yes, we do have a class. So tomorrow the class is at 5 o'clock, and then we'll be doing what? Redox reactions. Okay, and that is the last 11th chapter. Yeah, that is the last 11th chapter. Is there anything else which I missed? Yeah, that you can tell me that this thing S block is missed. It will be taken care, right? We'll do it at the last. Okay, all periodic table together. We'll be doing it at the last, right? So next class, I'll be taking redox reaction. I'll be completing it. That's it. There is nothing much we are going to see there, except for how to balance it, right? And then there is something called as volume strength of hydrogen peroxide, hardness of water, how there is a formula for calculating hardness of water. You know what is hard water, soft water, all these things. So there's a way to calculate hardness of water. So I'm going to give you the formulas and we'll do some problems. Anything else is there in the chapter? Yeah, nothing else. Okay, so tomorrow your 11th syllabus will be over, and after that I am not going to teach you anything, in the sense that if at all it is not covered in NCERT, definitely I'll teach you that, right? If not, yeah, I will tell you tomorrow what chapter we'll do. You will study the chapter and come, and we will do only the problems. And obviously I'll be explaining it. It's not like I'm going to give you the question and ask you, and I'm just going to wait to give me the answer, and I'm not going to go for the next question until you understand. Don't worry. Okay, so after we finish redox reactions, okay, after we finish the redox reaction, we'll go for organic. Okay, so there are a lot of other reactions I didn't complete, right? All the name reactions, other specific reactions I didn't complete. So that again will go for some I'm expecting some 3-4 classes. Okay, so after that there is going to be electrochemistry, chemical kinetics, solid state, what else? Surface chemistry, metallurgy, solutions, and then coordination compounds. Polymers, I'm not going to teach you. I am not seeing questions coming from polymers in chemistry in everyday life. I am not going to teach you that, because it's going to be, I can concentrate on some chapters which is having more weightage than that. I have never seen questions coming from this polymer chemistry. Okay, so after that we'll go for your S and P block and stuff, right? So February 15th, correct, is your JEE mains.
23rd, sir.
Third, sir.
23rd. Okay, so approximately if I calculate, so tomorrow one class, and then say I'll assume that 5 classes are going for organic, so 6, and then electrochemistry and chemical kinetics together 3 classes, so it will become 9. Solutions, solid state, say I'll put 3 classes, that will become 12. No, I'll just put 2 will be fine, right? So 2, that will make it 11. And what else is there? Metallurgy 1 class, 12. Surface chemistry 1 class, 13. Then yeah, and your obviously that entire periodic table, let's say 1 day 2 groups. Again, if I coordination compounds is there, fine. So coordination compounds to 1 class, so it will become 14. And then you have last one is the periodic table. Periodic table 2, that is group 1 and 2. Then group 13, 14, 15, 16. Or if I do 3 groups together, 1, 2, 3, or 1, 2, 13, 14, 15, 16, 17, 18. Okay, 3 days. So 3 classes. 17 classes. I think we should have some extra classes, guys. Other than we are already doing extra classes. We need to do some extra classes at least. No, if you say that it is going to be 23rd, but I don't want to go till 23rd. At least 1 week I should give you to see. Okay, I'll tell all this. So 1 week before that, so 23rd 1 week means it is going to be 16th or 17th. Okay, I'll keep it as 15th. Okay, I will try to complete everything by 15th, all the chapters I told you. And in the last 1 week, right, last 1 week, please do not touch your notebooks. Please do not touch your notebooks. I think excellent people have given you a software to write the mock test and stuff. Okay, write 2 mock tests per day. If you can write 3 mock tests per day, wonderful. Please go for it. Okay, so in that 1 week, if you're going to do 3 mock tests per day, almost 21 mock tests you'll do. At least if you can make it at least to 15, 16, 17, you like say without doing it, if you're going to go whatever mark you're going to get, you are going to get triple or 4 times the mark you are going to get in that exam. JEE means. Remember it. Please do not study. Done studying. I will be teaching you till 15th or 16th or whatever it is. Last 1 week, 3 tests per day. Obviously you'll write all subjects together, right? So at least minimum is 2, right? If you can make it 3, super wonderful. I'm telling you, how much ever test you write, that much percentage of marks you're going to get higher and higher and higher. Okay, so 3 tests per day, almost 20 tests you will write. And obviously you leave last day. At least if you can make it to 15 tests, 15 to 16 tests, if you write it in that 1 week, you are really going to do well. I'm telling you, right? And obviously after that, you still have time. You still have 3 more attempts, right? But make sure that first attempt is always best. And obviously you are going to get only better after that, right? Say you are going to get better, but not only you, everybody who has, who's going to write the exam are going to get better. There are more and more tests they write, right? So the more and more beforehand, more and more mock tests you write, more and more is the marks. Please remember this. Okay, now that I have like the very what to say, the very strategy, the easiest strategy to clear not only this competitive exam, any competitive exam is not studying. No, it's not that. It's mock tests. Mock test is the key strategy. Okay, so as many mock tests you write, see the same happened with me. I am a live example. Okay, I wrote almost like I didn't even calculate how many tests I wrote. Approximately before my JAM exam, joint admission test, I almost 30 mock tests. Believe it or not, 30 mock tests. And for that itself, almost like 20 or 25,000 people wrote, and I was able to end up only in top 500. right? Now imagine the size of your competition. It's going to be 15, 16 lakh people. 10 times what I wrote, 10 times the competition I had. So imagine how many tests you have to write. Okay, so this is an eye opener for you. I think this is the live, or I am the live example for you. I wrote 30 mock tests, and it's not about the knowledge, people. It is really not about the knowledge. Okay, I wrote 30 mock tests, and I was able to end up in 489 or 493. I'm not sure. It's below 500, top 500. That's what I was able to make it. But I was expecting in top 100 for the amount of preparation I did. But no, competition is really too much. Okay, so please keep this in mind. If today itself you can start writing the mock test, super, go for it. Or today is too much, tomorrow you start. Like for some time, forget about your school. Okay, till you write your, it's going to be like a matter of 15, 16, 15, 20 days. Okay, so if you can do that, see how much you mark, and trust me, sir, you will come and tell me, sir, I followed what you said and I got this much marks, and you don't have to thank me. Please thank yourself because you at least followed what I said. Right? Okay, guys, I'm not going to take much of your time. Please go have fun. Right? But again,
sir, but for the revision exams, it's actually studying for the school is actually being quite useful, because like somewhat I'm able to revise the formula. So yeah, the revision exams are going to happen for us.
I would say, see, what I understand from you, all of you, not only Varun, all of you are pretty good at concepts. All of you are, I think all of you are already doing well in schools. Okay, but JEE is a totally different thing. If you are interested, if you really want to show that you're gonna get some good ranks, right? I would really suggest you till when is your board exams? Board exam, did I give you a date? May, right? May. Oh God, like do not even give half a dash about, I'm telling you, school exam revision. Please do not do it. Please do not do that mistake. First, this 20 days, even if you're gonna just pass in the revision exam, it's completely all right. If at all, if you want, I'll talk to your parents. Right? I'll tell them that this is pretty more important. Right? I'll tell them that your kid will be able to do far, 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 far better in the board exam. I will guarantee them. I can even sign a paper and give it to them. Right? If they tell that no, do not concentrate on JEE and concentrate on both, that's what is going to help you. Let me. You have my number. Call me and ask. Call me, and I will speak to them. Okay, do not worry about your board exams. Do not worry. Either way, if you want to prepare for this and you have written so many exams already, you will definitely do well in your board exams. But JEE is a different level. Competition is also high. There is no ranking system in your board exams, but there is ranking system in that, and based on that, if who knows, right? If you really prepare well, you might end up in a good IIT or NIT. Right? But if you do well in board exams, already I know that you're in CPC, you will not be able to compete with the state board students. Eventually, you're going to end up in a bullshit college. Sorry for the language, but still, that's the truth. Okay, eventually, Anna University or some maybe Shastra, whatever, my college, right? So those kind of mediocre institutions, that's what you'll end up with, right? But if you're going to prepare, even though you wouldn't clear it, but you are going to be one, you say, in among 1,000 people in your mediocre college, but you will not be a mediocre person. That is for sure. You will be one above the crowd, even if the college is going to be a little okay-ish college, but in that college, you will be somewhere on the top. That is for sure. If you're going to prepare for the board exam, not for the board exam, JEE exam. Okay, so this 20 days, tell your parents that I have to concentrate on this. If at all my mark goes down in revision exams, ask them not to worry. And if they're still saying something, that you always have me. You always have my number. Please ask them to speak to me. I will counsel them. The person who needs counseling is not you. It's your parents. If they're going to if you're going to say that, no, please concentrate on the board exams, and I will do the counseling for them. Okay, fine. Any other questions? Okay, guys, fine. So we'll meet tomorrow. Okay, so from tomorrow, I think I have to go a little fast, given that we have some little amount of time, or I have to take some extra classes. We'll see how we are going to do it. But don't worry, by 15th or 16th, I will finish all the portions. Okay, right? Fine. Thank you so much. We'll meet.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you, sir.